Hi Engineering Janta, I am Vaibhav Shukla and today we'll be learning the code implementation for the circular queues. Fine. So for those who need to understand the basics or the introduction of circular queue, you can go ahead, watch the previous video. This is another video in the free DSA series that we are building for you so that you thrive high in your career. So let's go ahead. But before I dive in deep, go ahead, follow these social media handles so that you never miss any hiring update, and do comment out whatever doubt you have or whatever you feel about this video, because top 3 comments might stand a chance to win Prep Insta Prime subscription for free for 3 months. So you shouldn't miss that golden chance. Fine. Let's go ahead, dive in deep. And for all those who have studied the implementation of linear queues or the normal queues from me, they know that what this declaration is, but again, for you people, I'll do this out. So we are actually implementing the circular queue using an array. Fine. So you can consider this array as something that we have here, and we have a few partitions in it. Fine. Now, this array I declare, basically I dynamically allocate the memory. I declare a front PT, which is the front pointer. I declare the rear PT, which is the rear pointer. I declare the size variable, which will store the size of the array that I'm going to take to implement this particular circular queue. Fine. Now, I say that the size that I initialize is 5. Fine. So 0, 1, 2, 3, 4, these will be the indices. I guess 0 can be written in the center of this particular memory location. So once it is done, you create a new array of this size, which is 5. Size gets assigned, you create an array. Then you set front PT and rear PT equals to -1, which is you set rear PT here -1, front PT also here, which is also equal to -1. Fine. You set these two values. After you set these two values, what you do is you go and implement the enqueue function. Fine. This is a function which will return true or false value. That is why it is declared as a Boolean function, because these two operations we have to implement, enqueue and dequeue, and that will help us knowing how circular queues are implemented. Okay. So in this case, first of all, to check whether the queue is full or not, what you are going to do is, what conditions can be there to check whether the queue is full or not? Very simple. When one condition can be when front PT is here. I'm just telling you about conditions, so don't imagine much about it. Fine. So front PT is here and rear PT is here. When it is like this, you know that your queue is full. Fine. This is one condition. There are multiple more conditions, and we'll talk about them as soon as we keep on implementing this particular code piece. Fine. So right now, queue is not full, so this if block will not work. When will it work? We'll speak about it. Wait for a while. Right now, understand that queue is empty. Fine. So front PT is equal to -1. This condition is true. Once this condition is true, you set front PT is equal to rear PT equal to 0. So basically, when this condition is true, when you have front PT as -1, what do you do is, you set front PT here. You also set rear PT here. Fine. So rear pointer is also here. Now you set both of them to 0. I'll remove this out because you have implemented it. Because imagine that we were performing this enqueue. We were doing this enqueue 10. So we are trying to put 10 inside this queue. We are trying to put this element inside the queue. Now when this particular block, this else if block executes, this cannot be true, this cannot be true, as simple as that, because front PT was equal to -1. Here front PT is not equal to 0 and rear PT equal to size -1. So this is not true right now. Fine. This particular condition is not true, so this complete condition will get rejected and this else block would not work. So we go ahead and what we see after this else will also not work, because that if block has worked, so everything else would be ignored. Fine. Now at this point of time, what you will do is, at the rear PT, you will store the value. So basically this step would push the value into the queue. Right now, what is rear PT? If I write it here, rear PT, this is right now 0. If you correctly remember, see, rear PT is pointing at 0. So if rear PT is 0, then array of 0, what does it become? 10, because value that we were trying to enqueue was 10. Here, the value that we were trying to enqueue was 10. So this particular value becomes 10, and henceforth 10 gets added in this queue. Simply. Fine. Itna clear hai? Now, you imagine that there are many elements here. Fine. You imagine I enqueued another element. Let's check it out. Now, when I do this, it returns true. Fine. Now I go ahead and what I do is, you have to carefully think that at this point of time, I will do this enqueue. If I do this enqueue again, I add 11 as an element. Now what will happen? Now at this place, 11 has to come, isn't it? So 11 is the new value that I'm trying to enqueue. Is the queue full? No, queue is not full. So this if block will again not work. Is the front PT -1? No. So this time, this complete condition becomes false. Henceforth, this block doesn't execute. Now, rear PT equal to size -1. Is it like that? No, it's not. It's not like that. So if it's not like that, what will happen? This else block would execute. Now this else block would execute rear PT ++. So right now rear PT was 0. You increase it. Rear PT becomes 1. Fine. Once it becomes 1, what you do is, you do the array of rear PT. You come out of this else block. You execute this particular statement. So array of rear PT becomes array of 1 equals to 11, which was the value that we want to enqueue. So what actually happened here was that this rear PT got incremented. It came here. Fine. It started pointing out here, the rear PT, and at this place I add 11. Fine. Now front PT is pointing out here, rear PT is pointing out here. Simple. Easy job. Now, if I keep on adding multiple elements, I keep on enqueuing multiple elements, what will happen? So we have understood this particular portion. We have understood this else portion of it. We have understood this statement. Now we'll understand what if it is full, how to check if it is full. Fine. So I'll create a hypothetical condition for you where it is full, and just imagine that there is a position where you have filled it like this, 12, 13, 14. Fine. So now this complete queue is filled. In this case, rear would be pointing out here, isn't it? Rear would be pointing out here, rear PT. The rear pointer is pointing out here. In this case, what will happen? The queue is full. So this condition becomes true. Front PT is equal to 0 and rear PT equal to size -1, which is size is 5. So 5 - 1, 4. Rear PT's value is 4. This becomes true. If any one conditions out of these becomes true, you see out or you print that queue is full and you return false. You do not add anything out. Fine. But the careful thing to see is, I have not explained you this condition. Fine. I have not explained you this condition. I'll come to this. Wait for a while. I'll come to this. I'll explain you this as well. But once we reach that situation where this particular condition can occur, then only I'll explain you that. Fine. Now, let's go ahead and find that if you had done some DQ. Fine. So I erase all this, and right now you also haven't understood this else block. So very soon it will come. Very soon you'll have a situation where you will be using this particular thing. Fine. Now I do the DQ. Just imagine that this complete Q is full now. Fine. And I do the DQ portion. What I'll do is I write DQ and let's check whether the DQ works or not, how it works or how it doesn't. Fine, so let's check it out. So in this, when I go to the DQ function, first thing you check is the particular Q empty or not. Fine, so you check if front PT equal to -1, then the Q is empty. If front PT is -1, then Q is empty itself. No, you're not having anything in the front, so it is empty. Q works on first in first out, so anything would be DQ'd from the front itself. Now I go ahead. In this case, if the Q is not empty, what will happen? You declare an answer variable, or ANS you write it, and to this answer variable you put array of front PT. Front PT is right now 0, so this is actually 10. 10 gets assigned to it. Now you check if front PT equal to rear PT. When single element is present, this becomes true. Remember, when we had added just 10, then front PT was 0, rear PT was 0. At that point of time, this would have become true. But right now it is not true, so this would not work. Now, if front PT equal to size -1, which is the last index, which is 4, is front PT 4? No, it is not. So this is also not possible. This will not work. Now, if it will not work, then what will happen? You do this, you execute this particular else block. Fine. So front PT gets incremented and your front pointer is actually incremented. Right now here I left out this one statement. This is also being executed. The array of front PT. Fine. The array of front PT. Answer was getting the value of array of front PT, and now array of front PT, which is array of 0, would be assigned -1. So here -1 is being assigned, and now you increment the front pointer and everything works. You return the answer. So what is happening actually? Let's check here. What's happening? I told you, first of all, if this is not empty, then this particular element should be stored somewhere. Where it should be stored? I stored in answer, which was 10. Once I did this, once I stored this 10, I replaced this with -1. So this -1 represents that DQ has been executed here. Let me write a better one for you people. So this is -1. Once -1 has been occurred here, what would happen? I told you, increment the front PT. So this front PT is incremented, and here it comes. Fine. Now in this case, now the journey becomes interesting. Now in this case, if I further DQ, the normal DQ would keep on happening. Fine. Because in DQ you don't have anything else. But if I do not do the DQ portion, if I do not do the DQ portion and I tell you that I will add again an element. Right now if you see, front PT is here, rear PT is here, right? I need to add an element. Fine. At this point of time, what can I do? All I can do is I again write NQ, and that is why it is a circular queue. I add some value which is 17. Fine. Now if I want to add 17, this queue, had it been a linear queue, it would have shown the queue is full. Fine. But here in circular queue, this 17 can be NQ'd here. Fine. How? If you go here, the 17 comes here, you check whether the queue is full or not. So front PT is not 0 right now. So this condition is not true. Fine. Rear PT is actually size -1. This is true, but this is not true. So this condition gets rejected. Now this condition becomes valuable, but we'll come to it once we add 17. Fine. Once we add 17, we'll again do some NQ and this condition will become true. I'll show you how. Right now, just leave it. So this is not true. Right now, both the conditions are not true. You ignore it out. Q is not full. We have one space. Now if front PT is equal to minus 1, is front PT minus 1 right now? No, it's not. So this is also not true. So if rear PT, this block is now functional, this will work now. Why? Rear PT is equal to size minus 1, which is the last index. Yes, rear PT is equal to 4 because size was 5. So 5 minus 1 becomes 4. If rear PT is equal to 4, is it 4? Yes, it is 4. Front PT not equal to 0. Let's check. Front PT is pointing at 1. Front PT is equal to 1. So it is pointing at index 1. It is not 0. This is also true. This is also true. So this condition becomes true. You adjust the rear pointer to the 0th value. Fine, or the 0 index. You adjust the rear PT to 0 index. You recalibrate this. See, what I am doing is I assign the value of rear PT here. So rear PT is pointing out here now. Simple, isn't it? Very simple. That is why it can come back. That is why it is circular in nature. That is why it is a circular queue. All those people who were finding doubts in the first video, this will clear you out in a very practical manner. Fine. अब देखो, ये rear PT यहाँ आ गया. If I want, what should I do? This else will not work now. This will not work. Fine. Let's remove this out. Let's remove this out totally. So this will not work because one else if block has worked. We need not to worry about this. And now it will straight away come here. So array of rear PT. So rear PT is 0 now. The value that I want to add is 17. So this particular value where minus 1 was stored will now become 17. Now if you carefully see, the complete queue is full, right? The enqueuing has happened, but the queue has become full. Now if I want to do one more enqueue, I write enqueue 21. Fine. If I write this, can you add 21 in this? No, you do not have space. But how do you check it in the enqueue? You go to this enqueue function and you add 21 here. Fine. So you add 21 here. Fine. This is the value that you want to add. Front PT equal to 0. No, it's not 0. So this condition is not true at least. This condition is not true in any case. This particular one condition. But let's check this condition, because if any one condition out of the two is true, then this particular whole condition becomes true. Fine, this whole condition will become true if this part और this part alone becomes true. ये और गेट है बीच में, ठीक है, और लॉजिक. सो इनमें से एक भी ट्रू हुआ तो ट्रू हो जाएगा, ठीक है. अब यहां पर रियर पीटी इज इक्वल टू फ्रंट पीटी माइनस 1. ये मैथमेटिक्स करके देखते हैं. तो रियर पीटी क्या है? रियर पीटी इज 0. फाइन, रियर पीटी इज 0. फ्रंट पीटी minus 1. So front PT minus 1 is 1 minus 1. This is 1 minus 1. Modulus size minus 1. Size is 5 minus 1. So basically 0 modulus 4. When you divide 0 by 4, the remainder or the modulus operator would give you 0. The remainder would be 0 only. Or the result that you get after applying modulus operation would be 0 only. So in this case, rear is also 0 and this particular portion, this mathematical operation is also resulting into 0. So this condition becomes true. That is why this condition was important. That's how you check whether your cyclic queue is full or not. You now check that rear pointer or rear PT is equal to front PT minus 1 modulus size minus 1. मैंने दिखा दिया आपको ये करके, ठीक है. We'll again check it, don't worry. But right now, you can see that it is full. This condition becomes true. Hence, you print C out, Q is equal to full. Let's for a while imagine, एक और example लेते हैं. Imagine that had your rear PT and front PT. I am removing all this. And let's imagine that your rear PT would have been here. And your front PT would have been here. अगर ऐसा होता and you try to enqueue a value which is 54. If you want to enqueue this, can you enqueue this? No, this is full. But how do you check it in DQ? Let's check it out. Very simply, we can check this out. Now see carefully. I am going to add 54. So if I add 54, front PT not equal to 0, fine. So this particular condition, this much condition is not true. Let's check the other part in the OR logic. Rear PT, here rear PT is 2, fine. So this is 2. Front PT minus 1. What is front PT? This is 3. So 3 minus 1, fine. Size minus 1. Size is 5, 5 minus 1, fine. So if I do this mathematics, this becomes 2 modulus 4. So if I divide 2 by this, so 4 zeros are a 0 only. So 2 is the remainder you get. So this is equal to 2 only. So modulus operator would give you the result as 2 only, isn't it? So this is also 2. The result for this is 2. Rear PT is 2. The result for this is 2. Rear PT is 2. Both are equal. This becomes true. Q is full. That's how you check this condition. Okay. That is why this condition is important in circular queues. And that is why I was telling you, wherever you see the percentage symbol, remember it is a circular queue being implemented. याद करो limitations वाला वीडियो, नहीं देखा है तो जाके देखो limitations वाला वीडियो, ठीक है? In that video I had specifically told you percentage symbol is used in circular queues. I'll show you the usage of it. Fine. So this is the usage of it. देख लो, मैंने बोली थी ये बात. तो जो भी लोग circular queues से पहले limitations of queues पढ़ चुके हैं, they can easily recall this. Fine. And whenever you see in the linear queues, if anybody implements this, remember it as a circular queue implementation. Now you can easily tell this in interview and you will get some extra brownie points from the interviewer that you know better. So this is all about the implementation of circular queues. If you have any doubt, anything in your mind, go ahead, tell me in the comment sections and do subscribe it, because I'll be building more DSA videos to guide you out, to prepare you for free. This is free of cost guidance. So go ahead, subscribe to this channel, comment below this video if you are facing any doubt, and whatever good you learnt in this video, whatever you felt that was very good, very knowledgeable in this video, go ahead, spread that knowledge for free. Spread that. Keep doing good for others without any expectation. Good will come back to you. That's all for today. Have a wonderful day ahead.